Okay, so we move forward with little breaks in the usual stream of lessons for the training. So we now focus on the implementation of Spice here at ESAC. So basically, this is done by the ESA Spice service. Leads the operations for the ESA planetary missions and actually also for solar orbiters. So the group, which is me, okay, so but as Chuck mentioned before, hopefully by the end of the summer we're going to have another half person, so it's going to be me and a half. So basically, the main task that we are responsible for is the generation, development, and maintenance and archive of the Spice kernel datasets for the ESA planetary missions and solar. So Spice kernel dataset is the collection of kernels, the complete list of kernels that you need to run a given mission scenario, and that includes the meta-kernel. So we also develop and operate software in order to generate the kernels out of the orbit, attitude, telemetry, time correlation packet information that we get from the missions. And we also provide consultancy and support to the science segments, science community, and basically we also organize this kind of, this is really bad. Okay, this is better. So we work with this spectrum of missions, so to speak, from missions in legacy phase to missions in operations and missions in study phase. So, one person to maintain them all, it's kind of hard. Anyway, and we also provide an instance of a geocache and cosmographic configurations for those missions, and we will discuss that further on. So you can access our homepage, which is linked somewhere else, and it contains all the information that you will need for the ESA Spice service, and also information on the Spice kernel datasets and the other services that we provide. Unfortunately, the page is not fully up to date. I've done several improvements in the way that we manage and we distribute the kernels, and those things are not reflected there yet, basically because I didn't have time to update the page. But you can navigate throughout the page, and you'll see the links to particular missions, to the different services, to the operational FTP, and so on. And now I just want to outline maybe a little bit the particularities or the differences that you will find whether if you use data produced by Naive or any other NASA entity and the one that we produce. And this is a long and dense slide. So, as I mentioned before, our main purpose is to provide you with complete, consistent, high quality as much as we can, validated and up-to-date Spice kernel data sets for the missions that you are interested in. Okay. So basically, when we talk about the Spice kernel dataset, as I mentioned before, we consider a complete set of kernels that will cover the full mission lifespan. It will go from, basically, for example, for JUICE we have long-term study trajectories up to reconstructed orbit data for ExoMars from last week. So that's the range. That's the range of data that we cover. Basically, let's say at the Spice kernel dataset level, we differentiate in between two types of kernels, which can a little bit be defined in the boundary between text kernels and binary kernels, but it's not exactly like that. So when we have a Spice kernel dataset, we say that we have two types of kernels. To begin with, we have setup kernels. Those are typically text kernels, like the frames kernel, the instrument kernel, planetary constant kernel, leap-second kernels. Those are developed by us in partnership with the SGSs, the instrument teams, and Naive sometimes. And basically, these are, so to speak, can be more fixed in time. and they are developed by hand. On the other side, we've got what we call time-varying kernels, although it's not completely entirely true, in which we would have the SPKs, the CKs, the spacecraft clock, and the meta-kernels. So that would be mainly orbit, orientation, onboard time, and then the list of kernels that one has to use. And those we do not generate, typically we do not generate them by hand, but we use pipelines in which we process the source data that typically is provided by flight dynamics in terms of, for instance, orbit ephemeris messages, attitude ephemeris messages, or by the housekeeping telemetry data from the spacecraft. So the idea here is that we have a release mechanism for spice kernel datasets. So we have releases of them. And those releases happen whenever we update the setup kernels. So that's more like a manual process. For instance, yesterday we updated the ExoMars 2016 spice kernel dataset because we incorporated a new alignment for 2 bore sites of a given instrument. So that kind of process is manual, we do it, and we update the version of our spice kernel dataset. On the other hand, in the ExoMars case, for instance, which is in operations, we get new trajectories every week. Actually, we get new trajectories of different flavors, depending on the planning process that we are on every week or every month. Whenever one of those files is released, we do not increase the version of the spice kernel dataset. We simply tag with, we use a time tag that we add to the version of that kernel dataset. Because those are things that are being generated automatically. And that's why we differentiate in between setup kernels, which drive the releases of the spice kernel dataset, and time-varying kernels, which are produced by this pipeline. Okay, this is important to understand because it's the common approach that we have for all our missions. So that said, I would like to outline the importance of the meta-kernels. Okay, so far, like 3 years ago or so, we did not produce any meta-kernels for our missions in the operational FTP. We did that when we archived the kernels in the PSA, that I will just talk about later on, but we didn't have that for our missions in operations. And that was very painful for users because it was kind of hard for them to identify which kernels did they have to use for a given mission scenario, or for a given planning process, or for a given data analysis case. So now we provide the meta-kernels along with the spice kernel datasets. And therefore what we recommend you is that if you're working with ExoMars 2016 data and you are not in the planning process, you simply use the latest operational meta-kernel, because we ensure that the latest information is going to be available there and is going to be ordered in the appropriate way, as you have just learned in the lecture before. In the case of ExoMars, for instance, if you were in the planning process, then you also have a planning meta-kernel that only includes the data that you are interested in the current planning period. Okay? So, if you use our kernels, I can 99 or maybe 95 to 99% assure you that if you use the meta-kernel, you're safe. You might have particular requirements for your own studies, and then you should be knowledgeable enough to understand if you have to use something else. Now, as I mentioned before, this that I have outlined is already in place for all the missions that we are providing kernels for. So the way it works, in a nutshell, this generation of the spice kernel dataset, if we roughly classify the type of data that we use and the type of kernel that we produce, whenever we start with a new spice kernel dataset, as we are doing right now, for example, for the ExoMars rover, the first thing we need to do is that we need to model a set of reference frames of interest for the geometry computations that we want to perform. That comes in the shape of a frames kernel, and that's produced by us, so to speak. The next thing we want is models for the field of view and the bore sight that comes in the shape of an instrument kernel. And then we need some sort of predicted or a study trajectory and default or planned orientation for the main observer that we are generating the kernel dataset for. Typically that will come from mission analysis or even could be produced by ourselves. So that's kind of the minimal thing you need to generate a draft spice kernel dataset for a mission which is in study phase. And again, we have JUICE, Pepe Colombo, ExoMars, RSP, which is not actually publicly available, also Orbiter that are in that stage. Then, when on top of that we add operational data such as reconstructed trajectories, measured orientations from the telemetry on board of the spacecraft, time correlation packets for onboard time to UTC or whatever time format conversion, orientation of different spacecraft parts such as the Huygens antenna, or positions of scans, turntables, or articulation of the payload. Whenever we have all that, then we have a complete spice kernel dataset, an operational one. And basically, these things here are the ones that I tagged as time-varying kernels, as you can see here. And basically, the way that our pipeline works is rather easy. Well, for you as a user, you only have to know that there's some data providers, it goes through a pipeline, and then boom, they are published in our operational FTP. So basically, we have these different levels of status of a spice kernel dataset, which is in our operational FTP. We can have a draft one, we can have an operational one in the time that our pipeline starts to produce data. And then, from time to time, with a prefixed period of time, we will publish a peer-reviewed and validated set of the spice kernel dataset that we have in the FTP on the PSA archive. Okay, that correction of the kernels will feed back into our operational FTP, producing an enhanced version of the spice kernel dataset. And I will just comment briefly on that later on. So this is the current picture. I don't really want to go into detail on that, but green is good, red is not that good. Below ExoMars RSP, it's a bit of here be dragons, because these are missions that we actually do not have funding to support, and like we don't have much about Giotto right now, from flown in 1986. So if you look at the missions in study phase for what concerns the spice kernels, we are very good right now. For Pepe Colombo, Solar Orbiter, and JUICE. ExoMars RSP or 2020, we're just getting started and we don't have direct collaboration on that. So far, Solar Orbiter and ExoMars RSP kernels are private, so they are not publicly available. And then for what concerns the missions and operations, this is breaking down with the steps that I mentioned before. And the only thing that we are not in a very good shape at is at having reconstructed attitude, but that it's not necessarily one of our goals. When I say reconstructed attitude, I mean an attitude that has been processed, maybe using some enhanced navigation information or with images. Now moving on, and this is like the thing that I would like to stress the most, is how do we distribute these spice kernel datasets. So historically we only had one way, which was that we were publishing them in the FTP. So if you go to the FTP, you have the complete list of kernels that have ever been produced for one of our missions. There's a bit of a difference in between the old missions like Mars Express, Rosetta, Venus Express, and the new missions, so ExoMars, Pepe Colombo, JUICE, which is that if you go to the FTP for the old ones, you will see in the subdirectory of each kernel type, so we have them divided in kernel type CK, SPK, MK, LSK, you will see a former versions directory. And if you go to the new ones, you will not see them. Those former version directories were put there because the idea was that kernels that were superseded would be moved to that directory, and that would give an indication to the user that maybe you don't really need to download that kernel. But of course that doesn't necessarily work, and we have had different issues with that. So also following what Naive are doing, we basically with the new missions we have all the kernels in the same level, and that also gives us the possibility of always being able to replicate an older state of the SPICE kernel dataset. But again, this way to distribute kernels is not very efficient, and it's not very user-friendly, because, well, you got a list, you got just, I mean, you can also simply mirror the FTP, but, you know, it can be quite time and hard disk consuming. Of course, the ideal thing would be that you would just get the meta-kernel and get the kernels that are in the meta-kernel. That could be done by you yourself. You could set up some script that gets the kernels in the meta-kernel and do an update and synchronize, do an rsync maybe. But we've also found that users usually do not do that and struggle to obtain the correct data. So the thing that we have implemented recently is that we have now a way to distribute the subset of a SPICE kernel dataset based on the kernels in the latest meta-kernel with Git. So you can go to this link, you can Google it, and you can clone the Git repository for the Picolombo, Juice, Mars Express, or the mission that you want. And by cloning that, you will have the subset of kernels which is in the meta-kernel. It's using, you need to install Git large file system, which is indicated in the instructions over there. And basically this prevents us from overloading the Git repository with big files for especially SPKs and CKs. So the nice thing about this is that if you use this Git repository, whenever there's a new kernel coming in, you simply have to do a Git pull. And you will get the new meta-kernel, you will get the latest SPK, and the SPK that is superseded, for instance, will be gone from your system. This is also interesting because this is the way that we maintain our instance of WebGeoCalc and of other processes that are coming in the future, other services, so to speak, that are coming in the future. So this means that if you use this approach, you are sure that if you check anything with WebGeoCalc, that you will see later on, you will be using the same data. This is also really interesting for inter-institutional work. So this also ensures that you're using the same kernels as your colleagues are using. So there's no divergency in that respect, at least. So again, this is all based on the meta-kernel, and I just want to stress again the importance of it. I have here, so let me see, I'm running out of time. No, still have 10 minutes. So you're going to hear a lot about WebGeoCalc and Cosmographia. We're going to have a demo tomorrow on WebGeoCalc and a demo on Friday on Cosmographia. The only thing that I wanted to remark is that we have configurations available for Cosmographia for the missions that we have a SPICE kernel dataset for, since it's also a very nice way to validate the SPICE kernel datasets. And the same thing goes for WebGeoCalc. We have an instance of WebGeoCalc for, ideally, I think that it's the case as well, for every meta-kernel that we have, for every mission that we have. We also have some additional, let's say, subsets available for different things, like test scenarios, but okay. I mean, the thing is that the important thing is that the operational ones for the missions that we maintain are there. There's another thing which we are working on, but unfortunately not as much as we would like to, which is that we are putting in place different Python packages based on, well, using SpicePy, in order to provide higher level functions than the ones that are available with SPICE. So this basically comes from requests that I have had from different users that maybe were not SPICE experts, that wanted to get given quantities which are not directly available as a SPICE API, but as a combination of different SPICE APIs. This is also very useful for my day-to-day work, because there are certain things that I always need to get. So the idea is that I'm putting all these things in this Python package, for instance, PyOps. It basically contains this that I just described, also some non-SPICE based functions such as plotting capabilities of different kinds. And also simplified object-oriented interface to SPICE, such that you can use simpler grammar to load objects and obtain given quantities with them. Again, this is just an idea which is nice for me and nice to share, and the scope is to have like a multi-user, multidisciplinary, reusable SPICE-based functions. This is also a very good interface for me to provide solutions to users, so it's much better that instead of providing a solution to a particular request from a user, I can provide with a function or with, again, yes, well, basically a function that would allow the user to reuse or to use again what he's been asking for. This is available in the Python packet index. It's also accessible via Bitbucket. And although it's taking shape right now, there's a very old version available now that I should update. But we are doing the same with other packages that we're developing right now. So, you know, stay tuned, take a look, and well, it's just that I wanted to mention that it's there. So the last thing that I wanted to do was a brief introduction to the BSA. It's not that they pay me, but well, I have a close link with them. So the BSA is the Planetary Science Archive. So before I go into that, as I mentioned before, it's important to distinguish in between the operational FTP, in which we have the SPICE kernel datasets, and the SPICE kernel datasets that are archived in the BSA. Again, the ones that have been archived have been peer-reviewed. Usually they have been reviewed by Naive, by myself, and they are PDS compliant, so following the PDS 3 and or the PDS 4 standards from the Planetary Data System and the IPDA. So when you produce kernels in an operational environment with automatic scripts, that is prone to error. Sometimes we have coverage gaps. Sometimes there's just a pipeline has bugs and it can introduce wrong data. So that's when we actually look for those things and consolidate the SPICE kernel dataset in order to provide with a consistent and reviewed set of kernels that can be used more, let's say, with more confidence for data analysis or whatsoever. So the idea is that the Planetary Science Archive is a repository of ESA missions for the exploration of the solar system, and it contains special science datasets as well as engineering datasets for the spacecrafts and instruments that are hosted by the BSA. Again, it uses the PDS standards, PDS 3 and PDS 4, a common format that is shared by other international planetary missions. And it has the commitment to provide ESA mission scientific, mostly, and engineering datasets for decades to the public. It's part of the ESDC, the ESAC Science Data Center, and basically it's the node from which this data is distributed to the science community for them to produce scientific results. You can access the web page, and this is the constellation of missions that are available for the BSA. SPICE is yet another collection or bundle that is part of a mission on the BSA. In that concern, we're not in very good shape right now. It's shame on me. Okay, it's my fault. So this slide is the same that I shown 2 years ago. So these last updated lines for MEX, Rosetta, and BEX hasn't changed. And shame on me. So, for instance, the latest SPICE collection that we have in the BSA backs to 2013. So you don't really want, I mean, people are not really using this data. People are using directly the operational data in the FTP, the operational FTP For Rosetta, it's 2016 March, and for Venus Express, it's even more shameful because, well, it's long gone now, and we still don't have the full coverage of the mission in the archive. So this is coming. In principle, for Rosetta, it's coming during summer, and for MEX and BEX is coming on the fall. Now, that's for PDS-3. For PDS-4, it's coming for ExoMars in September 2018, and that is coming because I have a hard deadline on that, so that will happen for sure. The rest, people are more relaxed, but this is coming. And then, of course, the Colombo will follow. ExoMars RSP will come later, and Choose, as well, someday. So that's the bulk of what I wanted to say. So as a conclusion, just some remarks. Again, we are still on this process of moving towards providing you the best SPICE kernels that we can for our planetary missions. We're not done yet, so it's work in progress, as I've shown you in the table in the chart that I've shown you before. One thing which is kind of just what I said, we need to focus on providing the SPICE kernel dataset in the archives, and this is happening as well. We have now in place releases, we have mailing lists, release notes, and so on and so forth. So basically, the way that we used to communicate that, we have different distribution lists, mail lists that you can join if you want. It's kind of easy, SPICE _ the mission acronym, and then @sciops.esa.int. These slides are available in the FTP, so you can check that. I'm also in the Open Planetary Slack channel. I don't know if you're familiar with Slack, but it's a very nice way to communicate, much more efficient than email, by the way. And we have amongst us a person who was also very keen on this, which is Nico, right? Slack, yeah. Open Planetary, that's good stuff. And then, again, we're open to, so to speak, collaboration. So we are aware that, for instance, many NASA missions produce their own CKs while reconstructing attitude information and so on and so forth. We are not aware of any other agent in Europe that is producing SPICE kernels that could be fed to us. They used to be in the past, but not anymore. But anyway, if after this training course you become SPICE producers, do not hesitate to contact me. I'll be glad to see if we can incorporate your kernels in our SPICE kernel datasets. And again, maybe in a couple of months you can come back to the slides and take a look at this package that I'm just mentioning here. You might find it useful. And well, the other thing is that, as you can see, we provide these training classes. In theory, it's in a biannual basis, more or less. So we don't want to overload the naive guys who are also providing training classes in the US every 18 months or so. And we also provide some half-day workshops. So, for example, we're going to have a session in the PSC this year. It's going to be much more oriented to a hands-on lessons being guided throughout hands-on lesson. And that's everything that I had to say. So we're on time for the coffee break. If you have any questions, yes? Yes, in principle, I have uploaded them in the FTP. So it was not there last week, but it's there now.
So the SpyOps is using spiftp stuff. So could we use that package also, not only for ESA, but also for NASA's missions as well?
Yeah, absolutely. Mm-hmm. Yes.